Hey everybody, welcome to C++ Now. Thank you for choosing my talk for the first talk of the week. There are a lot of great talks this slot, so the topic must have been really interesting to you all, and I think it's really interesting. One of my goals for this is just to see what kinds of discussions we can have as we talk about these concerns, right? So, requirements for C++ successor languages, right? That's me. The subtitles might be, nice syntax, can I ship it? Or maybe, how replaceable are C and C++? And I'm not here in this talk, I'm trying to not promote C or C++ or bury them, right? I'm trying to talk about, well, how do we even evaluate? Is it time? Is something ready? Which things are ready? Those sorts of questions. Should I, in my capacity as an engineer, be recommending my organization invest in C++ to solve the problems that we're concerned about? Should I recommend we find ways to divest from C++, right? Hi, you may not know me, so I'll introduce myself a little bit. I'm the lead of the C++ infrastructure team at Bloomberg in the developer experience department. A large part of that job involves large-scale code-based management activities so that we can do things like upgrade our version of C++ or categorically eliminate certain kinds of bugs from the code base, that sort of thing. And I would definitely be a stakeholder in conversations at Bloomberg to answer the kinds of questions I was just asking at the beginning of the talk, right? I'm very active in ISO, specifically the tooling study group. I'm quite a bit less active in the other study groups, but I think about tooling a lot when it comes to C++. I find it's under discussed and under considered, I would say. I'm a career long, been in systems level programming in different ways. I have a long list of languages I've been involved in and have actually been paid to write at one point or another. I'm sure you all have a long list of your own. But the point is, my point of bringing that up is I, just like probably all of you, have actually used a lot of different tools for a lot of different jobs. And I think that's okay. So we're at CppCon, but it's okay to talk about other languages and how they work together, because let's all be honest, that's part of our job, right? Even if the other language is make or bash or Windows bat file syntax, you're using other languages on a regular basis, right? So this is a kind of a subject that could really go all over the place. So parameters for my talk, I'm trying to keep it within a certain bounds. And I think that's because I think these bounds are, again, under-discussed and under-considered within the context of how do we talk about the future of C++ and the languages that would also be in this space. First of all, this is a syntax-free talk. This is kind of unique maybe for a C++ Now presentation, but I'm not going to be pulling up a bunch of examples involving curly braces and where they're types on the left or the right. Those are all fun things to discuss. Let's all talk about it in the hallway. I'm not going to get into that here. I think other people are probably better qualified to comment on that stuff anyway. Including, I'm not going to talk about what safety is or whether C++ is included in safety or could it get to safety. I'm not going to talk about language design in general. I'm not going to talk about memory models and whether you can use this object in that language versus whether it works in C++ or whether you can communicate across ABI boundaries, which is tricky, right? I'm not even going to talk about the different languages and whether they're mature or not. I think that's a very important criteria, but it's a very fluid thing for a lot of languages right now. Even on the more mature end of the C++ successor language spectrum, there's still people saying, well, just give us some more time. We're going to see more things happen really soon, right? So for this discussion, just for the sake of discussion, I'm going to grant there will be at least one language at some point that will check all the boxes that we're concerned about with respect to can something compete with C++ and C in that space. Does that make sense to everybody? All right. It may or may not be fair to grant that. Maybe you would like to also argue that nothing will ever get to that far, and that's fair. But again, for the sake of this discussion, I'll grant that something might reach that point. Okay. I'm also going to be considering C and C++ together. Okay, since this is C++ Now, I will grant you that C/C++ is not a language. It is not. But for the purpose of this discussion, their ecosystems overlap so much that, and the fact the way people talk about C++ needing a successor, they're almost always talking about C in the same breath. I think it's worth, let's just talk about them together. Because again, we're all polyglot engineers. How many of you have written C in your career at some point? Basically every hand in the room, yes, right. So something really interesting, and maybe this is, if I could contribute one thing to the discussions we're having, is maybe about semantics of all things. What is a successor? I actually looked in dictionaries, and in the English dictionaries, there are multiple definitions that have subtle different meanings, but actually have a really big impact when we're talking about languages. And more concretely, people mean different things when I listen to them and I try to understand where they're coming from. They might just mean, I want to create a new language that's in this space that's going to do cool things that'll teach us about computer programming and language design, right? So when they say successor language, they just mean, this is awesome, it's going to have some cool features, and it's going to teach us about new concepts, right? Not like C++ concepts necessarily, but nouns are hard, right? They might be talking about another language, right? Like I'm okay with C++, but I also want this other thing sometimes that might be a better fit for some of my jobs, but I'm okay with C++ being there, right? Some people mean that when they say successor language, right? By the way, some language designers that own, or in different ways, the existing successor languages would consider themselves in this bucket. Just almost all of them as far as I know. And then the third category would be specifically a different language. Like I don't want C or C++ in this code base or in any code. You should be getting rid of those things, right? And so those are three different definitions of successor. So like that's something we should think about when we're talking about successors, is to help clarify to people, well, what do I mean by that, right? And I think that third bullet point I'm going to touch on a bit, because I think it's kind of a new thing. I mean, new languages aren't new, right? We've had new languages forever. So why is this a new thing? And it's hard, in the context of this talk, it's actually hard to discuss because there's so many people that are involved in this discussion, right? And Bjarne and other people have pulled up the analogy of the blind philosophers and the elephant to describe, like, how do people describe C++, or what is C++ to them? And then the analogy is, for the video audience, if nobody else, that you have blind philosophers looking at an elephant, they're touching and feeling around an elephant, describing what they see, and some feel maybe a tree trunk, and some maybe feel a serpent, and some maybe feel a wall, or maybe some sort of a weird fan. They're all getting different takes of what an elephant is, and to them maybe that's what an elephant is, and people feel the same way about C++. The problem is when you're trying to criticize C++ or address criticism of C++, you kind of have the same problem in a negative way, right? Everyone sees a bad part of something, and they're all describing maybe slightly different things. And so how do you address all these concerns in one talk? That's a challenge I'm going to have. So some of you might hear what I'm saying and hear, well, that's not what I think, and fair, right? But some people, everything I'm bringing up here are concrete things that people bring up about C++, right? And in particular, here's a particular example, just so you know I'm not attacking straw men. This is Alex Gaynor has been involved in the Python community for quite some time. He's involved in the Rust community. He's a technical advisor and consultant to different kinds of CTOs and tech leaders. He's written a blog post, and the link's there. Among the things he said, if you are using C and C++, it is to the peril of hospitals, human rights dissidents, health policy experts. It's bad for society, bad for your reputation, and bad for your customers, right? So that I would put him in the third category of wants to get rid of C and C++, at least for the situations he's worried about, right? And I think this underscores this. We as professionals, I'm assuming everyone here is a professional, but even if you're just avocationally interested, you should have a position. Like, what do we think? What do we do this year? What do we do in the next 5 years, right? So, on to the meat of the discussion, I think. The requirement summary, if I had to give you like the one-liner, is this. Like, we have a requirement we're under discussing, and that's you need to have good adoption velocity, and you need to minimize as much as possible adoption friction when you're talking about making any sort of breaking change. And yes, switching languages is a very breaking change in your code base. Note this is a point for all kinds of changes you might want to make in your code base. That could include things that people want to break in the C++ standard. It could include adopting a new package management standard or a package manager for your code base, right? Or adopting a new monorepo perhaps for your code base. It might involve changing significantly used C++ ABIs, whether for your code base or maybe for all your users around the world in an open source context or in a paying client context. These principles are all very generally applicable. So even if you think, hey, Bret's a lot of hot air about language successors and things, at least maybe you can help we can maybe crystallize some of our thoughts about like, well, how do we break things and what's a healthy way to do that, right? So hypothetically, I've talked to CMake and CMake core contributors about this. Like maybe it'd be interesting to have a CMake syntax, because one of the biggest criticisms about CMake is like maybe there should be a better syntax than the macro-based stuff that we're using right now. Fair enough, but we would have to talk about this sort of stuff, right? So to break it down into more points, this is a kind of a roadmap for the next part of my talk. We need to support existing ecosystems, broadly defined. We need to support incremental change, again, somewhat broadly defined. We need to support unordered adoption. We also need to support the whole development experience, both during and after the transition periods. To kick that off, supporting existing ecosystems. I'm being a little broad when I talk about, let's talk about this. When I talk about ecosystems, it's interesting when we're talking about C and C++ in particular. And I think that's because of their nature. And again, this is maybe something we could take away, even if you don't agree with everything else I'm talking about, is they're kind of unique in the space. Because I think it boils down to them being at their core just systems languages as such. And I think there's a lot of things kind of in this space, right? And I think these are all maybe systems languages, right? Maybe one of them, I think people argued about Go because maybe you couldn't implement a good garbage collector in Go, but for some people's definition, it's close enough. Like maybe your core build tools are in Go, and so that's close enough to be counting as a system language, right? So what do we mean by that? Do you have a question or a comment?
I'm curious where you would put Fortran.
I'd put it in a systems language also, I would say, because you can, and people do implement core libraries, for example. So Fortran, specifically, in case it didn't get picked up. Yeah, so the question was about Fortran. I think I would put it in here. I don't think it's especially interesting what I think about whether it's a systems language, but if you're interested, I'll answer. But the point is, like, I think the use cases are kind of unique. It's not like you see in other languages, right? And some of it is, you need access to the hardware. And this is a quote from Will Crichton, who's in the Rust community very heavily. He's talking about how C, C++, Rust, and D, they need to not have that extra abstraction from the low-level things in order to get their jobs done. And that's really important because every ecosystem on some level needs access to those things. And some languages, and some ecosystems, and some frameworks don't have a good way to get to those things. And so it's very common to drop down into a language that can do those things. And often assembly is not satisfactory for hopefully obvious reasons. So people are trying to pick languages that are powerful enough to do what assembly does, but in more maintainable ways, right? So it's very important. So inherently, because of this, C and C++ are meant for polyglot ecosystems. They're not on their own in a vacuum where there's like, they're not a planet in their own in a solar system. They're inherently connected to other ecosystems. And again, this is broadly defined. It could be operating systems, could be different kinds of build systems, like how do you build your code, like how do you ship your code, maybe even your business models, and I'll touch on that a little bit later, a little bit more. Deployment models are actually really interesting, right? Like you don't think about that as being part of an ecosystem, but really how do you get your code when you're done with it into the actual hands of the users is really important. And like if you make a big breaking change in your ecosystem, switching to a new language, switching build systems, and that breaks, that's actually critical. It's not a small thing, and it really needs to be considered very seriously up front. So let's pick some more specific examples. Hopefully this will help you all like get your juices going and understand maybe where I'm coming from. For existing ecosystems. So I think if you want to supplant C and C++, you have to be really serious about specifically having some sort of a CMake support feature. And I think that might be surprising to some people because they really hate CMake. But like given the amount of adoption we have, and it might be a majority at this point, it's definitely a plurality of build systems that you see in C++. If you want C to call your code and you do not support CMake, you are very much hampering what you're trying to ship. And that's just at the bottom line. Whether it's fair or not, that's how it works. That's too big of a breaking change, I would say, if you can't support that. Similarly, even maybe more shocking to some people, the configure and make workflow, and if you're a Windows engineer, that's just how a bunch of system stuff is built in the POSIX world. like also needs to be supported. And it's the reason it needs to be supported, and the reason a lot of these projects that do this configure and make workflow and don't use like CMake or a more modern build system is because it's so low level. They think it's so important that they are that portable or they have that long-term support as long as they have. Like they want to say, you can build my code with nothing but bash and make. And I'm just gonna assume everyone has make, right? And that's not a bad assumption. And so, because it's held up for so long, if nothing else, right? Similarly, you don't want to make your projects choose what to support. You want to make the projects that should be taking should be adopting what you're proposing. You don't want them to make hard choices, right? You don't want them to say, well, do I drop support for these architectures that my clients also need to use, that are already using, that they have to support? So if I drop that architecture, they have to drop me or something, right? And that's a transitive requirement. So maybe your direct dependencies are fine, but maybe their dependents, dependers, I guess, maybe the people that use you are fine, but the ones that use them are not. And that's a very hard thing to communicate across those boundaries, right? Similarly, supporting, like another example would be supporting building against pre-built binaries, which might be shocking for a lot of already popular C++ ecosystem like competitors, right? And partly that's just because that's how code is actually, again, delivered right now in a lot of cases. In the POSIX world, for Linux and Unix package managers, it's extremely common to just download a binary and put it on the file system. And that's how it works. Like there exist package managers that would grab the source code and build it on the fly as you need it to. But by and large, they're gonna download a binary that's somehow validated as being trustworthy and provide build instructions or conventions in some form that you would just link against that binary directly. And so if your language doesn't support that, then it's going to be unadoptable again. So the bottom line for the adoption friction here is, so to be more concrete, there's actually a page on the curl website by Daniel Stenberg, and they just had a big 20-year anniversary. I think it's 20 years. So it's a very successful project. I'm sure all of you have used it, and indirectly, even if you aren't familiar with it directly, right? And there's a page and it says, why are you still written in C? Everyone knows C is the worst language. Why aren't you doing my language that I love? And Daniel had a really thoughtful reply, and even a reply after that. But the pull-out quote I would say is that things that worked in curl 15 years ago still work like that today, the same way. And that's in the context of like configure and make workflows, and you have C APIs that everyone can just rely on and they don't break, right? And so if you can't get curl to adopt adopt the change you want to make, and that blocks other things from like everything that uses curl now has a hard decision to make because curl's that popular. And maybe somebody can re-implement curl in Rust or something. But there's a broader point here. And not every library is even important enough to be rewritten that way, right? So that was supporting existing ecosystems. And again, the point was things are more connected than maybe we think, right? In ways that you don't really pick up in an abstract syntax tree, right? Something like that. We also need to support incremental change. Ideally, we'd be talking about bubbles of code, so to speak. And this is a term I picked up from Sean Baxter a few months ago at a meetup we were having. But small changes add up to big migrations, like they actually enable big migrations. There's a spectrum of how small you can get. And ideally, you would get as small as you can. And so the requirement here is a bit flexible, but the point is if it's like, at a whole repository getting cut over at once, especially if it's a large repository, that's actually a really big ask. And we've had problems in Bloomberg with especially large repositories being able to adopt fairly obvious changes they need to make because of just the size of those repositories, right? So just to visualize it a little bit, let's start with the broad principles. So this is kind of an application of a broader principle that we're all familiar with, the idea of like doing things one step at a time, right? The journey of a million miles starts with a single step. And we can apply it to version control and don't have long-lived feature branches. They're really bad. It's hard to merge them. You have to keep updating and yada, 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 right? Same thing for code review. You don't want big code reviews. Who likes a giant code review? Like nobody, right? It's horrible. Agile principles, similarly, I'm not talking about the methodologies, but the idea of always be giving your customer a preview of what you're working on so you get that feedback loop again, take lots of small steps when it comes to product ownership and alignment, right? To visualize it, like we could have two graphs. One is a nice smooth slope, and one is a much more jagged graph that you could adopt. And again, one of those might be, well, I hit that giant library that I couldn't convert, right? Obviously, you want to adopt for one or the other. You don't want adoption cliffs. An adoption curve is maybe something you can manage. An adoption cliff can actually kill your project in the middle, where actually maybe the downsides are still higher than the upsides at that point in that project. And maybe that you lose funding at that point or lose interest from your community, right? So Titus has a lot of good talks about refactoring code at scale, and I think that he's elaborated on this in a lot of detail, but I'm just gonna steal some of his thoughts here and use it here. But if you're gonna execute a large and distributed change, you wanna do it in a series of small steps such that the ecosystem continues to build and function cleanly at every step. And keep in mind, this is as you're changing languages, not just refactoring an API or something, right? But each step is small enough to be handled as part of a normal developer workflow. Most steps shall avoid explicit sequencing requirements, and that's a preview to the next point, the next section of my talk, right? Here we go. Nice segue. So support unordered adoption, which is slightly different than granular adoption, right? Again, Titus, just to continue that thought, a multi-step refactoring is going to be much smoother, much easier if you can do it in such a way that when you're updating the callers, you don't have dependencies on which of them gets updated first. There's some implications to this, right? That means if you need to provide an API that's being converted, you might need to do it in two languages, right, at the same time. And we've done that before, right? You've maybe had C++ wrappers for C APIs and that sort of thing, although we usually do that manually, and we all know how the costs. If you've done it manually, you know what those costs can look like as you're trying to juggle, well, I need to make this change here and this change here, and how does that work, right? So I'm going to just illustrate it with some visual aids. So I'm going to do a simulation. We're going to mark every node in a graph, and there are going to be two options. One is we're going to do it in a sequence such that you can only mark the next node if the previous nodes are already marked, right? Does that make sense? All right. Option B would be just mark whatever you want, as much as you can, right? So some parameters just to make it interesting. I think these are actually pretty conservative parameters. I think they'll be much worse in real life situations, given my experience. But we're gonna say each resource works exclusively in converting one node at a time, and a resource might be maybe an employee, right? A node takes, let's say, 2 weeks to convert, which that's pretty realistic for a pretty big change for a given project or a given component of a large project, right? And then maybe say you have 4 people on a team that's working on this nonstop, and they're just dedicated, right? And again, in real life, it can actually be much worse. The characteristics of the results could be a lot worse. If you're working on volunteer-based conversion projects, it could actually be quite a bit worse. Dedicated employees are relatively nice on the spectrum of how you can get things converted. So let's look. I'm just going to click through. So let's talk about the first one. So let's say in the first 2 weeks, you use one employee to convert the first project because it's down at the bottom, it's the bottom project, right? But you had 3 other employees doing, I don't know, taking HR training or something, right? Not what you wanted them to do, right? And then maybe you had 2, again, maybe you had some more parallelism next, and you could, you have a little more, you're using your resources a little bit more, but again, you have some other ones that aren't being used. And again, if you're talking about volunteers, this is where you run the risk of they got pulled onto something else. Then you have choke points, you're down to 1, still choked. Okay, now it starts to open up a little bit. But at the end of this, we only started using even 3 or 4 resources towards the end, and that's pretty realistic in my experience. So it tends to be towards the leaves of a graph where you start having real massive parallelism. But it took us 14 weeks in this case, right? And I had a lot of yellow and red text here to show you like, oh, that's not great. And I guess you can live with it that you're kind of wasting a resource, but that's not a great use of resources, both in terms of latency and in terms of expense, right? Now let's do it again, but with unordered adoption. So just 4 arbitrary nodes, 4 arbitrary nodes, 4 arbitrary nodes, 3 arbitrary nodes. We're done in 6 weeks. That's half the time. Like I said, in my experience, and maybe y'all have different experiences, we could talk about that. That's actually pretty optimistic for the 14-week case was actually pretty optimistic. It could actually be quite a bit longer. So let's talk about the ordering a little bit. Not captured in this graph are exactly why you're picking which nodes and when. And when you have unordered adoption, you get maximum flexibility for that. Which projects should convert first? which ones are the ones we should convert the most. And this is a very important point to stop on, is because a lot of the discussion about C and C++ right now are around safety and around correctness. And so arguably, if you're very concerned about divesting from C++ and C, you want to target the things with the worst correctness problems, the most use, the most outstanding security bugs or something like that. And if you're in an ordered adoption scenario, you're not targeting this thing. You're not targeting E yet because you're still working through the graph to get to it in the first place. You should be able to target things that are critical for a broad definition of critical early, and you should be able to dedicate as many resources as you can to getting them done faster. The other thing about this scenario that's not realistic is I said every node takes 2 weeks. In reality, some things will take 2 weeks and some things might take 6 months because it's just a very hairy problem, or that team has other projects they're dedicated to, or that maintainer, that volunteer maintainer just stopped responding to emails and now you gotta figure out ownership again or something, right? So let's talk about how realistic was that graph I showed you. Like I said, it's kind of an optimistic scenario. This is a more realistic graph. Anyone know what, any ideas what this is? You probably don't because I just made the graph. But this is all code like you're familiar with. This is Vim. In the Bloomberg code base at least, these are all the things you build. Every little dot here, they're tiny because it's a big graph, is a project that gets built until you can get to Vim. And Vim is not an especially complicated project, at least not in my experience. This is a more realistic project. This looks like something out of a Petri dish, doesn't it? So this is a real backend service at Bloomberg. It'd be analogous to, like a containerized HTTP server or something like that. So if you wanted to get the top thing completely converted into a new, safer, better, expressive, productive, whatever the reasoning thing, and you have to walk through the graph, you better get started, right? And you better have a really, really fast turnaround time per node. So hopefully that illustrates my points a little bit about like why it was really important to have unordered adoption. We have much worse graphs than this, just for the record. And I think if you did this on your code base, I think you might be surprised about how complicated some of your graphs are. Oh, by the way, a lot of the code in here is open source code, the code you use. So it's things like readline and Perl and make and stuff like that. Yeah?
So that loops.
It does not loop.
It does not.
It is a guaranteed directed acyclic graph. It has some curvy lines. It may look like it loops. The actual Vim node is probably in that white cluster up in the top right. And there's a lot of the dependencies that branch out into large ecosystems, sub-ecosystems of other dependencies, right? Like all the things that go into build Perl or something, right? Localization libraries that have little snarls. We don't use any visual, we don't use Cairo or anything visual, like graphical in our Vim, I don't think. But ncurses has a lot of stuff under it, for example, that it'll pull in when you pull in ncurses, and Vim uses ncurses if I'm not mistaken.
That's like a package dependency graph, right? No, it's not
This is a package dependency graph, right?
It's not really like a code dependency graph. It's exactly the same, right?
Well, it goes back to my first point, is it doesn't matter.
Yeah.
If I can't build make for my ecosystem, it doesn't matter if everything else builds fine.
Well, if I want to adopt Rust everywhere, in one project, right? I don't have to rewrite make in Rust, right?
It depends on what the ecosystem requires, right? You're right, do I have to rewrite make in Rust? And the answer is maybe not. Again, this is where it gets more interesting about trade-offs. You could prune parts of this graph. I think it's fair to say some of this you could prune out, right? But I think the broader point of there's a lot more to convert, even in the subgraph you're interested in. It's at least gonna look this bad. It's probably gonna look worse than that though, right? But yeah, I mean, this is where it gets a little interesting. Depending on every ecosystem is something kind of called a bootstrap or a base image of some sort, even if it's just a binary that is a Quine that can self-validate. You download it from the internet, you have a checksum that you trust, and then it builds hex editors until you get a minimal GCC and a minimal Python or something, right? At some point you have a base. And if you have a fatter base image, you can cut a lot of this graph out. And then maybe you're building those things, maybe you're just downloading those things from the internet. And that's a pretty common practice when you're talking about this package level stuff. But there's also another comment is the biggest project in this graph is still a dot that big. So I'm not doing, if we did this at the header dependency level or the translation unit level, it would be much, much worse, right? So I think that's a fair point, and yeah, we can keep talking about that stuff. This point is actually maybe the hardest to illustrate because there's just so much to it. But it's actually really important, and I have seen projects fail to get adoption because of this specific point. And that's the whole development experience. What is the whole development experience? Well, it's what matters to you and what matters to the people that use the code you ship, really. That's a definite point of adoption friction that is very much under-discussed. This isn't something, again, that shows up in an abstract syntax tree, right? And it goes to like, is it software development productivity, and is the software development lifecycle disrupted by the changes that you're trying to bring about? Is this disrupted after the transition is done? Like, do I lose features after I'm done adopting your thing? Is it disrupted during the transition? Are there features I lose while I have multiple languages bouncing around in that little piece of code, right? And the longer the transition, going back to the previous 2 bullet points, the higher these costs are gonna be, right? So, like, examples. Do I have to refactor my whole CI pipeline? Like, how fast do I have to do that? How soon do I have to do that? A lot of times when you're adding a new language, there's a lot of upfront costs exactly on this bullet point. Can IDEs jump to definition across language boundaries? And that's a broader point. It also applies to code indexing and code search. It's all kind of the same problem, but like, can I identify when that thing makes a call, it's really referring to the other code in the other language? And that, just for development productivity reasons, that's really important. But in some contexts, you also have, especially when you're talking about safety and security, you have other requirements around making sure you don't have certain categories of bugs, you're not using deprecated things, you're not calling something that has a CVE against it, that sort of thing. Do code generators need big updates? Let's all admit it, we all use or use projects that have code generation. How does that work with multiple languages? Or with multiple, if you change the APIs that those code generators use, right? What about API documentation? Some projects, it's actually really, really critical for that project that they have docs that are accurate and legible, and their customers rely on it. So if you're having multiple languages and there's some sort of like parse and then generate documentation generation going on, how does that survive a language transition? Do you just say, well, you just have to, if you don't know, just search the new language and the old language docs, and you'll find the API in one of those, and where it'll be depends on how far along I'm in my transition. That's not a great experience, right? Again, static analysis checks, how does that work? How do I know if something's deprecated? How do I know when it returns? Like, does that work across your language boundaries? Deprecation warnings. Instrumented build workflows, similarly, like those actually have more ABI sensitive than your application in most cases. How do you make sure that if you're doing like a sanitizer build or a debug build, that things aren't just dropped on the ground, right? Coverage analysis is, at Bloomberg at least, coverage analysis is also a popular instrumented build workflow, right? This is important. It kind of goes back to the incremental change point again, but it's like, well, other major changes in your code base have to just stop or move out of the way for you to get the velocity that you need. What about foundational libraries? And what I mean by this is like the things that are the vocabulary, concepts, and ideas in your code base. And large organizations always have some of these, and even smaller organizations have some of these, right? Like feature flag systems, like logging systems, like things that for different reasons like to have process-wide state or process-wide singletons, or you have the same, you all have to have the same credentials or share the connection pool of the database, like that sort of stuff. Does that stuff all work? And do you have to, how soon do you have to sort that all out in the transition period? Anyway, so those are the 4 broad points. We could take a pause here if anyone has any thoughts about those. Yeah.
You didn't mention one adoption friction that I was kind of expecting, and that's the human one.
Yeah, that's a good point. Yeah.
In particular, you kind of touched on it with this, can IDEs jump to definition across languages? Right. But even if your IDE jumps to the definition, can the human read the definition that they've jumped to? Like how much cost do the humans have to pay?
That's a good point.
When they're working across languages. And I think it's particularly interesting to think about the human cost in 2 folds. One is kind of a retraining cost, right? If you're going to actually move into a new language. There's also a unique cost during the adoption where both languages are pervasive, and you have to be able to move back and forth between them fluidly if you're supporting code. And I think that's just kind of a easy to kind of overlook cost here.
I agree. Yep. Yeah, you're right. That would have been a good point to emphasize. So next time I'll have you review my slides. And, but yeah, I agree with that. That's something I kind of hint at again later in the talk. So yeah, that's something I very much agree about. I don't actually cover it as much as you did, so I liked your explanation there. But That's something we believe in. I believe in strongly, and at Bloomberg we also believe in strongly. Is that like it's really a whole experience, a whole package. You can't just say, oh, I only care about the language spec. You really have to care about the engineers that use what you're shipping. You have to care about their users even, right? So yeah, I agree with that. And I think we all experience that though, right? Because again, I've mentioned we are already dealing in polyglot ecosystems. One of the biggest pain points we have at Bloomberg is maybe there's a team that has Python bindings into native code, and they have bugs that span that gap. Or maybe it's in the native code and it's a team that mostly lives in the interpreted language area, right? So it's a pretty startling jump to have to go to a core dump if you're used to doing print statements in Python or something, right? So how does that work? Or how do you know that the APIs are any good? I've been there. There's some language binding for Python, then there are no docs. So you just like, okay, I guess I'm learning Swig or something so I could figure out how I can call this API, right? Or at the assembly level, this is one of all our favorites, is you can pop into Compiler Explorer anytime you want. You can look at the C++ code you wrote and how it translates into assembly, and you can get some intuition about, but that's a multi-language workflow, right? You could have written that assembly and would have done the same thing that code did. But you don't want to write that assembly. But sometimes you have to drop into it. And again, you've all been there, at least earlier in your career, that's a pretty startling jump the first time you do it. In fact, we have talks at these conferences about how do you make that jump, right? So I like that point a lot. So let's do a case study. I haven't replaced C++ in my codebase yet. I would gather very few of us have done that to the extent that I'm talking about. So this is the next best thing maybe I have handy. It's something I have a lot of familiarity with at least. So a transition we did make, which was a change in languages, was we converted our build systems at our entire codebase scale. Our legacy system was a GNU make-based build system. It was like a subset of GNU make, right? It was calcified, opaque. It was poor interop with other kinds of tools that needed to understand builds and things. It was very feature poor. It was very unapproachable to the users even, right? It was hard to add new features because it was so calcified. It was just like there are things we weren't doing just because it was too hard, right? Successor system, which emerged kind of organically from our C++ community at Bloomberg, was that, hey, it looks like CMake actually works for us in a lot of these situations. And so some community got together, our developer experience department jumped in on that, and we came up with a full solution for adopting CMake at Bloomberg. Had a much better developer experience. We had to bridge gaps where teams were like, okay, I'm used to this make thing, how do I pick up CMake and that sort of thing. Is feature rich. Contributor friendly, importantly, again, that's because we took the whole ecosystem. We were serious about training people to actually learn the ecosystem. Very extensible, so teams that could unblock themselves. If they had hairy problems, they didn't have to wait for anybody. And again, introspectable, meaning CMake relative to make, you can ask what targets are you building? And do you have any tests and things like that? And whereas in make, it's like, I don't know. Like, is that implemented? So to give you a feel for the velocity we had in the adoption, in September 2018, we had about 250 projects using CMake and using the mechanisms and tools and the support we had, where I'm talking about. And in about 4.5 years, we converted about 17,000 projects. So that's about 325 projects a month. And again, projects are pretty chunky. Some were big and some were really tiny. So it varies. Importantly, and I think this is important to point out, so you don't think that, okay, well, that's Bloomberg, they got departments for this and whatever, right? This is all self-paced, self-adoption in this case. We didn't have a mandate. Nobody was getting knocked over, like wrapped on the knuckles for not adopting CMake yet. It was very much adopt at your own pace kind of approach. And I think that would mirror a lot how open source projects and community-driven projects and multi-organization code bases would look like realistically, I think. Because as the ordering problem is especially bad when you have to get project management involved. Like, okay, can you get that done by April Q2? And then they miss the deadline anyway, and then everything's like y'all been there, right? So keys to reducing friction. Some of this is kind of summarizing and just applying, but we didn't have conversion ordering. That's why we could do self-paced adoption. If we did not have conversion ordering, that would have been this. We would not have been able to do this. And frankly, we probably would still be using the other build system. Complicated projects could convert gradually. Yeah, Barry, you have a question?
Yes, no conversion ordering. That kind of relies on none of your projects have to themselves build any other projects. So like, they don't have to know how to build anyone else. Right.
So our projects were able to do unordered conversion because we use package management. and because we already had a multi-build system kind of an environment where different projects were picking different build systems anyway, so it wasn't a new problem for us. So we have a build and install workflow similar to, actually it's literally a Debian system that's applied to our code base. So there's a build and install workflow, and then you install the library and its interfaces, and then you can build against those. And then we came up with some conventions very closely. It's more or less we use package config for metadata to kind of provide that interop between the build systems. We do think that the ecosystem does need better technology in that space because package config was a bit limiting, and that was the best we can come up with. And again, that's later slides I'm getting to, but yeah, that was a really good question. I think, and to be fair, we already had that packaging system in place. So if we were going to start from zero and do the conversion without a packaging system in place, we would have had to do a bottom to top package system conversion and then do, then we could maybe do an unordered CMake conversion. And again, that's something realistically we can talk about like what's the future in systems language is like, well, to get to the later slides early, like maybe if we're going to do a bottom to top, everything needs to get on board process, maybe that needs to be something that's more of a polyglot thing. And then maybe it's easier project to project to pick your poison or whatever, right? Anyway, complicated projects can convert gradually. So when I talked about incremental adoption, that's really important, right? So what they could do is, as maybe they're getting their CI system caught up on the new CMake feature within the CMake implementation, or while they made sure they didn't break any changes and they did some A/B testing in their environment or whatever, they could have both build systems in this case, right? Okay, you have the old build system, you have the new build system, you just have both wired up to CI, you ship one or the other or both, you can A/B test, and when you're confident, you can drop the old thing. And so that's really important, and again, we would not have had that adoption velocity we had if that was not an option for the engineers in our projects. There were definitely immediate benefits to encourage prioritization. I think this is kind of obvious to everybody, but I'm going to bring it up that it was actually really key. Like, I think there are a lot of successor languages throughout history. There have been C++ successors in previous decades that never quite got over the hump for whatever reason to really like compete in the same echelon or something. And it's not necessarily because they're even bad languages or anything, in my opinion. At least current opinions vary, but some people think that, well, maybe they just weren't that different enough, right? And I won't name too many names. Maybe some of them are popping up in some of your names. It goes not just for C++, it goes for interpreted languages too. Peter?
Is one of those immediate benefits of telling the current code base, I'm not supporting the older system, you're on your own? Is that another lever to get people to move?
Is one of the benefits telling people that you're going to drop support for the old thing?
It's not a benefit, right? It's a negative.
We haven't, as you know, because you work at Bloomberg, we haven't actually said we're dropping support for the legacy build system yet, even today. It's pretty obvious to engineers around the company that that's the direction, but there's not been an official decision like, yeah, we're going to drop it this year or something. That's something to consider. That's not what this bullet point's making. I could understand that consideration. I think, again, it goes back to my first point about supporting existing ecosystems a little bit. Like if you really change your service area of adoption, that can actually be an adoption hurdle in some cases. So you have to be really careful about that. Chandler?
Not on language adoption, but on other things, something that I've seen is that this kind of negative pressure, I think has a pretty harmful effect overall, particularly in the first half to 80% of trying to get adoption of a new thing. It can actually be pretty painful, and so it's something that at least on several other kind of major kind of move people from system A to system B. It's something that we've actually started avoiding because even if we are planning to drop support for the old thing, if we lead with that, it kind of sets the wrong tone and sours the entire relationship. We really want to lead with the benefits that actually accrued immediately to the people, and maybe only use kind of the more forceful things at the very end to kind of collect the long tail, because it just changes the developer sentiment. And I feel like trying to cause an adoption in the face of like negative sentiment is extremely painful and unpleasant.
And I think that's a hard problem to crack too. Like, that mirrors my experience at Bloomberg for large code base changes too. But it's a hard problem to crack too because like, let me put it this way. I think it's in general much healthier to say what about the new build system is so important that you couldn't that you need to drop the old build system in this case, right? So like maybe it's has better, again, let's talk about introspection. Maybe the new build system gives you better understanding of the code. It makes you make better product ownership, code ownership of your whole code base. Like maybe you don't drop the old build system. You just say, it needs to get the new features that we require going forward for understanding how your code works, however that works. And then depending on how your code base, this is where org structure is kind of weird. Like it depends on how you organize, like how you solve that
I
problem.
agree you would lead with that, right?
Yeah.
You're going to reach over the head to do something new, but I think there's probably at some stage right during your adoption where you flip over to say, it's kind of the negative thing is going to start becoming more of a, 50% of the people are on it, and this is going away. I mean, I've heard that many times when we go to.
I think you could get almost everything you want with a more positive approach about what you're expecting. So like maybe you're saying every project needs standard test, build, and run workflows. And your build system doesn't have a test target. Every one of you has a different test target. Like, so I can't interop with all that. So we need to come up with something better and drive it that way. And by the time you start talking about like, well, if every one of you went through the effort of getting that all organized, why didn't you just switch the build system and get it over with, right? And that's actually been really realistic at Bloomberg. More concrete examples, like maybe you work with software bill of materials like software supply chain is a big buzzword these days. Like maybe you have raising standards and you say, I don't care what your build system is, you need to ship an SBOM file, a JSON file describing what went into building your project. And like, by the way, if you switch to the thing that's already supporting it, and then we think that'll be about a sprint of work, you're gonna meet this requirement, that sounds great to project managers. Like, oh, okay, there's no hard engineering work, there's help to be had, there's documentation, I can have a junior engineer even do that sounds perfect, I'll do that. Whereas if you go to them and say, you have until Q3 to fix all your stuff, like at some point you're right, at some point you have to get to the last 5 projects and they're drastically underfunded. And even at that point, the way I tend to approach it is, how can I help you go to the people that need to say yes and get them to say yes to you to fund this project? Because that's usually the problem. Usually the department head, the team lead, or whatever that is like, oh, I'd love to do that. I just can't get my boss to tell me to do it. And that's usually what I do. It's like, okay, well, tell me what your boss needs to hear, or let's set up a meeting or whatever. That doesn't scale especially well, but if you get to the very long end of the tail, that works really well in most cases. But that's a really good point. I kind of referenced this a little bit, but like it's really important that when you come up with new technologies that you really empower your users, the users of this technology, and that was the case in CMake, is that you can, if you have a weird build, you have a weird custom code generator, you don't have to come to Bret and ask Bret to go implement your custom code generator. Like you just do it. Like as long as everything works with all the other systems, that's fine. And that's going to be true of languages too. So if it's like, can they write their own libraries? Can they write their own packages? Like, does it have the features they need? Can they contribute to your code base? Do you have ways for people to learn how to contribute to your code base? That sort of thing, right? Again, not technical investment. This is what I was talking about earlier. You definitely want to get involved in community bootstrapping. What I mean by that is you need to make spaces for people to talk about this thing and help each other. And yes, your core contributors and experts that you've either recruited or hired should be around to answer the really sticky problems, but if you can't get your users to answer each other's problems, you're not gonna get anywhere, right? Give talks at conferences if need be, right? Documentation, again, workshops are great. Like it really, really helps. You'd be shocked how much easier it is to get people to adopt something if you just sit next to them while they're adopting it. And they're not gonna ask questions that aren't already in the docs, but that just provides a lot of safety and comfort for this sort of thing. And sometimes it's as easy as, hey, we'll just have a chat channel open. And if you all get stuck, it'll ding on my phone and I'll help you get unstuck, right? That's the lowest effort amount, but depending on your culture, face-to-face or some Zoom chat or open Zoom chat or something might be appropriate. And that's partly because you want to actively foster local expertise. So you want to really grow experts all distributed around your community so that, again, they're the focal point. Everyone's not coming to you to answer every single question about how your compiler works. That you have people around that can take that load up. And they grow up to someday maybe taking over your job so you can move on to the next thing or something, right? Extra relevance with successor tools. So build systems aren't just an analogy, it's actually really concrete, and as an aside. A lot of the new successor languages come with their build systems and their packaging systems. And that's actually from this perspective, it's a missed feature. Like it's okay to have one, but if that's your only option, that's actually a really big adoption hurdle for large code bases, which includes the worldwide code base, including all the Linuxes and all that stuff, right? Like, it caused real problems. I don't know if y'all are aware of this, but it's like, in Linux package managers, often it's like, well, how do I build this project? Well, just show out to this other package manager, and then it'll ship binaries, and then you copy them in. And there's a lot of data you lose between those boundaries between package managers, just like there's a lot of data you lose between different libraries or different build systems or anything like that, right? It's just, there's a lot of detail you lose. Or maybe you have a monorepo and some of that's not as big a deal because your monorepo can just bridge the gap. I'm not sure it's that trivial, but or you have a small enough project that it counts as a monorepo, at least for your purposes. But again, that's fine if that can work for you. Do it, that's great. But if it doesn't work, but don't expect it to be like, okay, well, we're gonna divest from C++ now because I got that problem solved, just switch to my build. Everyone, put your C++ code in my package manager for this other language, and then you can convert it slowly. Well, that's 2 migrations, right? So now we have two enormous problems, and how do we do that, right? All right, so this is the implication section where I've touched on, hopefully illustrating, hopefully you understand where I'm coming from, and this is like, in my mind, some extrapolation we could draw from these. Yeah, go ahead.
You didn't talk about like mechanical or automatic translation between systems at all.
Yeah, that's true. I did not talk about mechanical translation between systems. I don't know if it's a strict requirement. We had some for a build system adoption, for example, but by and large, it depends on what you're changing and how big that change is. Some of the successor adjacent technologies, some of them don't even consider themselves languages, are arguably you wouldn't need it. You would just change some build flags or maybe something, or start using certain features that aren't compatible with C++, but you're using a new compiler. I'll pick one that nobody in the room is advocating for. It's like Zig. You're just switching your tool chain, right? Well, maybe some of you are Zig fans, but hopefully it's less controversial than other examples. But so you just switch to Zig toolchain, now it's Zig. Actually, GCC did this, right? GCC used to be C, and now it's technically C++ because they switched to the C++ compiler. So depending on what breaking change you're making, you may not actually need an automatic translator, although you probably still want static analysis to make sure you're being idiomatic, at least over time. I think that's an interesting subject. It's not something I'm an expert in, so I wouldn't deign to teach all of you about how to write transpilers or whatever you prefer to call those. I know some people don't like that word, or whatever other interrupt thing. That's something I'm interested in. I'm eager to learn more about. Any other thoughts? I have a lot of slack in my talk, so it's okay to interact a bit. All right, Chandler.
I'll just put out for a very concrete language migration example that I think folks can look at. It does go kind of the direction you're talking about with Zig or GCC, where it was an almost transparent thing, is TypeScript and JavaScript, where one of the specific strategies of TypeScript was to make it almost a no-op to adopt TypeScript in some senses. And so I think it's a really great and interesting example to look at, because there's trade-offs in that space.
Right, exactly. And I think the concepts I'm getting at, I think were in their heads, maybe not phrased the same way, but I wanted to help crystallize those, because I think, again, in our conversations, we're not crystallizing those in the discussions. Instead, we're getting hung up on other things, which I find less interesting, but maybe you like them. Anyway, and that's actually, like YAML in theory is a superset of JSON is another example of that. There's a lot of technologies where people bake that in, and they're like, yeah, we need this. And maybe they haven't expressed this way why that's essential to like those big ideas. Yeah, go ahead, Chandler.
There's the classic point, C++.
Right, C++. Yeah, right. I thought about making that point in this talk, and I don't know why I didn't put it in there. But yeah, C++ more or less used this strategy, right? When uncharitably they embrace extend, extinguish kind of thing, except extinguish with a question mark, right? Anyway, go ahead.
Yeah, my question was just going to be I agree with you that this all makes a lot of sense, but how much of this do you think is necessary upfront for a successor language? Because a lot of these things are going to be really difficult to get right on the first pass, and so I think that to get to this level of maturity for a solution, it's probably going to take a decent amount of time. And so how do you kind of see the way to break that gap?
Right. So I think these are requirements for speed and for momentum, is another way to put it. If you're willing to grind it out and you have infinite funding and infinite patience, and somehow you can pass the torch off from leadership to leadership to leadership over the decades, then perhaps you could take your time with it and do some bottom of the top thing. That has never really been done before. I mean, we're talking about so many decades that programming has only been around that many decades. So like, I think people should be, I think these are things to factor in when we're trying to estimate like what that horizon looks like, I guess, in my mind. And I think, importantly, if you're into the deprecation, if you're into the divestment camp, you're probably talking about much shorter timelines than you are if you're talking about, oh, I just want to sometimes write in a garbage collected systems language or something, right? Like perhaps you're like, well, as long as I can get it up in a container, I'm happy. Okay, you're happy, everyone's happy, let's move on, right? But C++ has plenty of other customers, it's gonna be fine, right? But if people are saying, I think there's some zeitgeist that's like, well, don't write C++ anymore, it's a bad idea. You should only be like looking at one of these new things. And this is my case for why I think that's a really premature point to make. Right? Let's at least be reputably within a decade of being at that point before we get to that point. And I think a lot of the people that listen to us talking about this stuff are at that point, and maybe we don't appreciate it. That they don't realize that we're talking about that long of a time, right? Right. So implications. I think, again, back to one of the first points I was making, I think the world needs cross-ecosystem languages. That is a thing that people want. They want the same library in their context of their Ruby application, their Python application, because it works and they just want to reuse it, right? Or they want exactly the same JSON parsing semantics or whatever that is, right? This is a slide from Bryce Edelstein-Lelbach had a talk at, I think it was a virtual talk at CppNow a couple of years ago, where he was talking about actually what goes into the standard library, but he comes up with this concept of what he calls universality. And he says, that's kind of unique about C++. It's like, we meet you where you're at. You can be at all kinds of contexts, all kinds of domains, all kinds of architectures, all kinds of programming paradigms. And C++ is there. And you can't say that about a lot of languages. Like a lot of them are like, well, that's too high performant, that's not a good fit. Or you say, well, you can't really reuse that unless you're using this packaging ecosystem. Like Smalltalk, for example, like doesn't even really do version control on files. So if you have to use Git and you're not writing Smalltalk or something, I don't know, maybe using Perforce, I don't know. I think aspiring languages are good. Maybe to the earlier question, like if you don't check all these boxes, it's not bad. But you're probably talking about a different definition of successor, perhaps. And maybe we should be careful about the phrase. Maybe C++ alternative is a great phrase that kind of gets to, well, I want to be in that space. I'm not trying to necessarily replace C++. Because one of the definitions of successor, as in like, we just had a succession of the British crown, is the person that comes after and replaces the previous, right? There's other definitions of successor, which just came later, right? And they're, again, it's a subtle distinction, but it's actually really important when we're talking about these things. The point is, if you think the horizon's that many decades out, then maybe the case for divestment's premature. We shouldn't be telling CEOs and heads of government organizations that we need to like penalize companies for having C++ still, because you're like, well, you're talking about changes on the order of switching to electric vehicles across the entire country or something like that. It's that big of a change. Plan for that big of a transition and plan to fund it that much if you're really that serious about it. And this is my embrace, extend, extinguish. Like, so were these successful successors? This is one of Chandler's slides. She goes, why not? These transitions are all here. They've all been made. A lot of people, their entire code bases have transitioned. But the things on the left-hand side are all around, right? We're still writing all those languages. I think like everyone's lauded a lot of these transitions even, and they're all good languages, but they're still here. So if we're talking about divestment, none of these things were really targeting divestment specifically, right? So like this is something that, depending on who you're talking to, TypeScript is not a good example of a successor language because it hasn't actually succeeded in succeeding JavaScript, right? Because we're still writing JavaScript, and some people think the future looks like everything compiles to JavaScript and you run it in your browser or WebAssembly or something, right? So anyway, how replaceable are C and C++? If you're not clear, my answer is it's going to take a lot of work. I'm not saying we couldn't do it, but there's a lot of work we have to do first. Shoot, it's even hard to replace C++ with C++ a lot of the time. Like, so there's like we're still not sure how to modularize C++. That's arguably a much smaller change than changing languages. Maybe it's more, I guess we'll find out. But even switching to like C++ standards on big enough code bases or ugly enough code bases can actually be a pretty big change. And the ISO committee tries really, really hard not to break people when they're making these decisions, and yet these things still happen. Otherwise, we would all be like, why are you not on C++ 20 yet? That was 3 years ago, but that's still a thing that people are working on. And it's because of the things I was talking about, right? Like you have to get everyone to convert to 20 in a certain order, or you have to get everyone to use the new tool chain all at the same time, so there's an ecosystem shift happening or something like that, right? Or more importantly, you have to drop support for the old tool chains that don't support the new standard in order to fully buy into the new standard, right? I think people that are advocating and pushing for these new technologies, you do you, that's great. I recommend that you don't build a straw man in your head that there's just a grumpy engineer writing technology that he likes or she likes or they like. That if they knew the thing I did and they knew how cool it was, or they just had a more open mind, we would be past this and everyone would be using the new thing. I think these are really hard problems. I don't think they're very easy problems to think about or even work on. Let's focus on those. I think you're gonna have a much productive discussion, much less unneeded controversy. There's enough hard decisions to make without like having extra friction in that space. In C++, does it kind of deserve a break maybe? Given all I'm saying about universality, polyglot ecosystems, how it's in all the ecosystem, like C++ doesn't have a standard package manager. It has all the package managers. That's why it's so hard to package C++. So does it deserve a break? Because that's kind of the job we gave it, right? We need libraries, we need languages that can do all these things. And like, these are hard problems, and arguably anything that wants to replace C and C++ need to be willing to tackle those problems. And if that doesn't scare you as someone writing a successor language, I didn't make my point very well. Right. That's something maybe you could push back on me in the Q&A. Right. So also, as we're discussing this week and future weeks, keep in mind that language and syntax concerns is a fraction of the problem. I know CppNow and other conferences like this, we have a lot of language designers or aspiring language designers, and that's great. If we talk only about language design for 95% of the discussion, we've ignored the other 95% of the problem. So I think I've elaborated on these points. I can move on. So concrete next steps, not just mean, hey, let's try harder and fix things. I think these are actually more specific. I think we need a definition of a library in these kinds of polyglot ecosystems. What is a library? Can I identify it? So we all know curl. Like, I'm going to bring up curl again. That's an easy example. What is curl? There is no standard for that at all. Like every build system just kind of makes up something. Every packaging system kind of makes up something. They have their own names. The names don't translate. They have maybe different interfaces. Again, there's like curl for Python, but then there's curl for maybe it's under the hood for requests or whatever, right? Like how do we do that? I think if we get some of these problems solved, we already have these problems. So we might as well solve them. And then if you're into like succeeding and replacing C++, this is something you could build on, right? Okay, well now that curl's written in this other language and nothing broke. Everyone still calls it curl. It's just the curl that's written in language X now, right? That would be the foot in the door for like how we might start developing packaging standards in a polyglot ecosystem. Packaging dependency management standards, it would also in certain ways apply to monorepo workflows and the kinds of things you need in order to like update the dependencies in your monorepo and things like that. Tooling standards, similarly, I think there's a lot of ABI level problems that are common that we haven't bothered to collaborate on. Like, how do you identify when something requires a certain version of a certain compilation toolchain? How do you identify the certain ABI assumptions that go into that? Everyone's solving these problems, but they're all solving them their own ways. And the more that people solve all these problems in their own ways, the harder it is to come in and make a new, interesting change in this space, including can I add a new language into the space? And this is not hypothetical. Again, like you brought up Fortran. That's one of the things that's interesting is, I don't know if you all knew this or not, but by and large, compilation toolchains assume that you are linking with the runtime of the program that is providing the main of that program. Meaning, there's not like a portable way to say, but what if I have C, Fortran, and C++ all in the same program, which is not that exotic. It happens all the time if you're doing numerical computations or something. There's no way to say, well, give me those 3 runtimes. Because by and large, the way you get those runtimes is you link main, which is unique, with one of those, which is very awkward. So like, it would be nice to have standards around, well, how do I describe, well, I need the runtime for a language, and how does the build system or what the packaging system provide that sort of thing. I'd like to see, again, because I think this is actionable, if we had some interop around compilation diagnostics, then you wouldn't have to have tools that you had to understand every single compiler across all these different languages and how to understand the error messages. You want to jump to the line of code with the error, right? So there are standards developing like Serif that could help with that. I think it'd be interesting to see us more aggressively ask our vendors or work with our contribute code to make sure that we can do that. So your IDE hopefully just knows it's a compiler. I don't care what language it is. If I get an error back, I can go find that line of code for you, right? I brought up software bill of materials and software supply chain. I think that's a really actively funded area right now. And I think that's something that we should be getting in on at the systems language level to say, well, if you linked in these shared libraries, you linked in these static libraries, it should bubble up. And like, so your program should be clearly exposed to certain risks, or even you can identify for your purposes that you're using something that you really wish you shouldn't, you really wish you didn't. Oh, you pulled in Fortran? Why did you pull in Fortran? I don't want Fortran linking in this application. But you would only know that if you had something that could transitively walk all the dependencies and find the thing at the bottom that pulled Fortran in, right? I have a hypothesis, it's untested, but my hypothesis is if C++ was already modularized by and large, it would be much easier to compete with C++. And to some degree, I think C++ has a moat, and C for that matter, and that moat is textual inclusion. The question about how do you build, like how do you translate between different languages, the whole idea of textual inclusion like scares the daylights out of me, and it's very complicated to have a very thorough treatment of like code transformation in that. There are technologies that are interesting, that they're developing maybe, but I'm not even optimistic that C++ modular C++ header units are even adoptable for some of these reasons. Because it's kind of a subset of that problem. It's maybe a slightly narrower problem, which would be like, if you treat importable headers as a dialect of C++, how do we make that dialect work with the dialect of included headers with textual inclusion or preprocessing? And I don't think that's a solved problem at all. My colleague Daniel Russo is giving a talk later this week about that and what we've been talking about in the tooling study group about how we might go about actually adopting importable headers. And spoiler alert, it's not super optimistic right now. So anyway, my hypothesis is if we had more widespread adoption of modular C++ interfaces, at least those interfaces would be much easier to translate into other languages because you'd have a much smaller, more consistent parsing service to consider. Anyway, and I think the bottom line, the biggest thing to think about is funding models. And that could look like recruiting volunteers for your open source community. It could look like getting governments to fund software bill of materials projects for your tool chains or whatever that looks like. I think that's a real bottom line here, is I think people might be surprised at how few people actually maintain like the ecosystem of C and C++, and how much momentum how much we're living on momentum of people that have already been contributing in different ways. And I would like to, in conferences like this, talk with people about what we could do to like provide better ways to actually work proactively on these problems. And I don't think it looks like writing ASO papers. It probably looks a lot more like organizational hacking, community building, and that sort of thing. I think there needs to be ways for companies that don't ship compilers as a product in some way to get involved in the health and maintenance of systems ecosystems, no matter what the languages are written in. Some of the newer languages are, by the way, taking risks in this space that maybe we haven't been eager to do in C and the C++ ecosystem, in the C and C++ ecosystems. Like there is, from what I can tell, for example, there are Rust projects that are being funded by different kinds of security and governmental organizations around safety and security, that they're actually developing the language and its ecosystem directly with funding for these kinds of research projects. And that's not, we don't have any space like that in the C and C++ ecosystems to just say, go here if you're worried about C++ security, and let's talk about projects that we can fund or even write grant proposals with or something like that to say like, hey, here's how we can get some advancement here. Instead, we have, it's very, because again, we have a diverse ecosystem. There's no central governance model, right? Like you don't have to go to the head of C++ and ask, can I be C++? The answer is if you wrote something and it uses C++, you are now part of the community. There's no like gating mechanism, right? The flip side of that is there's also no central like direction setting mechanism. So I don't think we need necessarily just one, but I would like to see more movement in this space. And it doesn't look like, talking about how exceptions propagate across language boundaries, it looks like actually implementing things like that, right? Anyway, that's the last of my thoughts. Does anyone else have any thoughts? Questions, concerns? Sorry. All right. Chandler.
I'll ask another question.
Okay.
One thing that I thought was kind of interesting is you talked about divestment of C++.
Right.
And I think that's an interesting term. I think that one important nuance is kind of, I think it's actually useful to separate different layers of which you might divest from a language.
Okay.
And so the example I'll give here, because it's kind of silly and easy, is assembly. And like how we divest it from assembly.
Right.
I think the answer is both emphatically no and also emphatically yes.
That's a good point.
And I think the way you draw the distinction between those two answers is actually really instructive. So we still use assembly everywhere. It's still a fundamental part of our technology stack. It's incredibly important, and no one's getting rid of it anytime soon.
Right.
But we don't actually invest in human beings, developers writing assembly, maintaining assembly by hand. That's not a place where lots of educational resources are put into it.
Right.
We don't build new IDEs or IDE features to make this better and so on. And so in some senses, I think we have divested the kind of developer experience of assembly. Right? Because we've successfully gotten everyone to go write their systems in higher level languages, which is good. And I think that if you look at I'm going to pick on the JavaScript TypeScript example because it seems much less controversial than all the others, at least in this crowd. I think that this is also a really great way to think about this. So on one hand, I don't think folks are divesting from JavaScript because it's going to still be the core of the web platform in a lot of ways. It's not going to go anywhere. You're going to run all your code on it, right? But on the other hand, I think we are genuinely seeing divestment of JavaScript.
Right.
Not from the web platform in any sense, but from a kind of developer perspective. Developers are going to genuinely stop writing JavaScript code. They're going to stop thinking hard about how to make JavaScript super productive. And they're going to instead be thinking about that in terms of TypeScript. And that's still a form of divestment. And I think it's an important one because I think it's actually the only achievable one.
Right.
And so to a certain extent, I think, to the extent that there is an effective successor language for the stronger meaning of the term successor, that is the
Right.
replacement thing, it can only go through this kind of human developer lens. It can't go all the way through all of the infrastructure because then none of these exist. Literally there are no successor languages if you take it all the way through all of the infrastructure except for maybe C.
There's probably some assemblies that are gone, but yeah.
But it's really hard to find anything where the entire infrastructure underneath goes away. And so I just don't think that's an interesting place to look. I think it's really interesting to look at when the developer population can largely step back from a language and not worry about it.
Right.
And when you do look at that, one interesting thing is it often is not tied to how much code is still written in that language. It's actually just tied to how much developers have to modify code written in that language. And so you might still have huge bodies of JavaScript code floating out in the wild, right? And that might be fine if developers are at no point really spending time or energy authoring, maintaining, editing, updating that code. Then we've essentially divested from the language it's written in. It's just an API service that we access. And so I think this is a bit of a more nuanced stance in between the alternative and the kind of very rigid definition of successor. Sure. But I also think it's the most interesting position as well.
Yeah, and I'm comfortable with nuance if that wasn't clear. That's part of what this talk is kind of trying to do, is provide some of that nuance. And if it needs to be more granular, I think I'm okay with that. I think I tried to get some of that with like maybe it's an alternative language, and even if it's displacing a certain amount, and maybe for certain use cases or certain organizations, they don't even use the other language, or at least not directly. I think there are still considerations, even if in the use cases you talked about. So you talked about like, well, maybe we're most concerned about what developers are actively maintaining and actually touching and changing. But like for security concerns, it doesn't actually matter if you change the code or not. What really matters is it exploitable or not, right? You have a comment about that?
I disagree with that.
Okay.
We have significant empirical data that code that does not change does not carry exploits. The exploits that are found in subsequent releases of Android, of Windows, of Chrome, of Internet Explorer, like you go through all of the software that's heavily attacked, they can absolutely track the rate of change going down and the found exploits going down all the way to 0. And so there's strong evidence that code that stops changing also stops being exploited.
This sounds like a case for leaving the C code alone, though, right? You're worried about security.
The only correlation here is a lack of change.
All right. But like, all right. And the other point was, the other thought I had, again, adding more nuance to the nuance is, there's different people you're talking to also. So like if you're talking to CTOs and you say divestment, that probably means, right? Like in the JavaScript case, well, then why are we funding SpiderMonkey? You're like, okay, well, you're not, yeah. So like if people are saying, well, let's get out of C and C++, you should still be funding GCC and Clang and LLVM, LLVM, maybe the new language is written in an LLVM backend, but the point is like those things still need funded actively, right? So like, what does divestment mean? It doesn't look like, well, we don't care about that stuff anymore. It looks like, no, that's still underpinning your whole stack. And in some ways, it's going to be harder to fund because again, people maybe aren't writing C all the time. And even in a third point of nuance, and I think we might have a comment or something, but is even in the assembly case, the lack of investment in the assembly case makes assembly much, much worse when you need it. The education's a very fair point. Like people just don't learn how to use it. Although the materials are there and it's not that complicated, but you know, but like for example, build and packaging space, like what's your project structure, your favorite project structure for assembly code or something? Like, okay, like it's like, I don't know, figure it out, right? CMake or something, and even CMake doesn't support all the assemblies, right? It has quite a few support for a few of them, but like, okay, so maybe CMake is again, like, well, maybe CMake's the systems language build system, fine, and we just add more assemblies to it. But like again, it didn't go away. The reason you're writing assembly files is because it was a better fit for that project to write assembly than even C with inline assembly or something, right? So again, that still needs investment. And I argue that we're in some ways suffering from the lack of investment at that level. So like maybe that's over divestment because we got ahead of ourselves in some ways. Was there another comment or question?
Yeah, I mean, just a quick, like on the assembly front, like there's very clearly been, like you were saying about a degradation, like, like 30 years ago when people wrote a lot of assembly, the assembly language was actually a much better language. The assembly language has massively degraded in the last 30 years because people are not investing. The assemblers are much worse than the assemblers 30 years ago. Right. Because people don't bother making really good macro assemblers for new architectures anymore because there's just not enough developer base to do writing assembly to make that worthwhile. I would, on the divestment front, I would say that like I do have some like quarrels with that name or with that term because like I would specifically say that like even as somebody who like will happily confess to like thinking that like we need to replace and get away from writing C and C++. Like I absolutely would not encourage a lack of investment in those things. I think what we're going to see and what I would push for is a change in the nature of the investment in those. Like, like a recognition that like we're going to have this code, like we're going to keep maintaining it, we're going to keep developing and extending it in many ways, right? But like, like the changes that we make to these languages should be oriented towards like a more mitigation style of evolution where we like recognize the most glaring problems in these languages and try to fix that while also paving way for migration to new languages, right? And that's as somebody who thinks that we need to replace them. So like, I don't think, like, divestment to me feels like the wrong term for it, because we do need to continue to invest.
I guess I'm flexible on the terminology as long as we're keeping the nuance in the discussion. And I think, again, that's why if we come up with other terminology, that's fine. But I think even, like I said, I think successor itself is kind of a overloaded term, so it's hard. And I'm not sure there's ever going to be a perfect word for this, but I do want people to think better about, especially in the casual conversations that we have with our colleagues about, like, yeah, no one's doing that anymore or whatever. Like, that we're thoughtful and say, like, no, like, we're going to need that, even if it's in a very more specific targeted form. I think one thing to think about is, like, let's think about the code in the world and how much it's grown since, like, people began programming, right? And it's clearly grown year over year. I don't know how you could prove it either way, but I would bet serious money that we've never shrunken the amount of code we've had in any year. And while certain projects have certain kinds of languages and technologies have shrunk, their niches have shrunken progressively over the years. Again, like, have they ever gone away? I don't know. Maybe it's hard to think of one that actually went away. How much have those niches shrunk, and how much of them have just stayed the same size while the rest of the world wrote more and more code? And that's something I've thought about. I don't know how to prove it. I didn't make slides because I don't know how to quantify that. But it's something I want to ask out loud, and maybe other people can think about it too, is if the code base is, like, it's possible that we've never had fewer lines of Fortran. We might have more lines of Fortran than we've ever had in history, right? And so, like, what do we say Fortran? Do we say Fortran is a dead language? I don't think that's fair, right? And do we say we should stop writing Fortran? I mean, I guess that's up to you. But, like, clearly there's a lot of people that use it and like it, and we use their code. So, like, anyway, there's even more nuance to the nuance of, like, okay, well, what does it mean to be a niche language anymore? And it's like, well, it might be a bigger language than existed when COBOL was around, right? So, or it was one of the big languages. It was one of the big 3 or 4 at one point, right? So, yeah, more comments? We have 5 minutes. We can keep talking in the hallway after this, though.
Super brief. I just want to mention, like, there's some good metrics you can get here. I really like tracking the amount of code and independently from the rate of change of code.
Right.
I think the rate of change is a great way to see things actually recede, because you can watch, like, the rate of change actually drop, whereas the amount of code never drops, right? It's always growing.
Right. I think that's fair. We could talk about both. I think good metrics, you have more good decisions. You have multiple metrics, and you're balancing them. Yeah, go ahead.
Yeah, one other question I had. So I was gonna say, I think one of the things that makes, like, the transition to a successor language so painful, and, like, generally makes migrations painful in software engineering, we all talk about Hiram's law, and, like, the fact that just, like, eventually there will be enough people using your code base that just everything has to stay exactly the way that it is now, because they all depend on something. And you gave the example of converting Perl over to, like, a successor. Sorry, not Perl. Curl over to its successor language. And to me, that would actually be pretty amazing if that was, like, implementable, just because Curl has so many users. And so I guess one thing I'm wondering about is, like, is this just a fundamental property of engineering at scale and it is simply unsolvable and there's really no point worrying about it? Or do you think that that's something that a successor language could potentially make less painful?
I don't think I think what I'm trying to say is I don't think a successor language is sufficient. Mm-hmm. It might be necessary, but, like, we need some higher level things. Like, for curl, you might need a way to distinguish the dependency specifically as I'm using the Rust curl or I'm using the C curl, right? For example. And there's not a lingua franca for that. And even more importantly, you might need to have specific versioning and specific ABI identifications, like, patterns. And that's why I said these are concrete next steps we could actually take. There's no reason a bunch of us couldn't get together and come up with some of these standards and start publishing them at future conferences or something. But like that's kind of where that's what I'd like to see. And so at that point, maybe you can ship breaking changes if the APIs are compatible enough. And maybe not everyone can adopt the breaking change, but it's close enough. And, you know, software is a messy business anyway. Sometimes you don't have to be perfect. But if you want the C curl to go away altogether, you definitely need to be perfect, and that's a really high bar. And maybe I'm arguing from absurdity a little bit, but that's partly because I need people to really understand, well, yeah, it is an absurd proposition to say, we're just gonna get rid of the C code, or we're gonna get rid of all the C++ code. Even if we're talking about, well, maybe it all stabilizes and we don't have security bugs, If that's where consensus falls, then at least we have a clear direction forward for everybody. And we just say like, well, we just leave the things that are already working fine in C, we're gonna leave those in C. And we're not gonna keep doing that, right? We're not gonna necessarily go try to rewrite everything, at least not as a broad policy, right? We do see people trying to rewrite things. Like there's a lot of Linux utilities, it's a really popular side project is, okay, let me go write this in Go or Rust or something. And again, they're pretty self-contained, so they don't really have the same, like, they don't have quite the same challenges I'm talking about in my slides. They have some of them, like, well, now that means to install that, to build that package, you have to have the new toolchain installed and things, right? Anyway, I think we are out of time. 1 minute? We have 1 minute. All right, we're not gonna use another minute. All right, I'll see you all in the hallways. Thank you.